In this video, I would like to explain about the algorithm. What is an algorithm? Actually, algorithm is a finite set of precise instructions for performing a computation or for solving a problem. So, in short, we can say that algorithm is step by step to solve the problem. A program itself is one type of the algorithm. All programs are algorithms, but not all algorithms are programs. For example, the direction to somebody's house is also considered as algorithm. A recipe for cooking a cake is also an algorithm. Or the steps to compute the cosines of 90 degree is also considered as algorithm. So how to create the algorithm itself? The informal definition of an algorithm used in computer. It consists of three parts. The first one is the input list. This is the input list, and then here's the algorithm, a step by step to solve the problem, and the process here, and then the output. This is the informal definition of the algorithm used in a computer. Some algorithms also are harder than the others. Some algorithms are easy, like how to cook noodle, instant noodle. It's quite easy. To be exact, we can also say that it is easy to find the largest number or the largest value in a list, or finding a specific value in a list. However, some algorithms are a bit harder, like sorting a list itself, how to sort the list so it can be placed in order, ascending or descending. Some algorithms also very hard. For example, finding the shortest path between Miami and Seattle. Some algorithms also essentially impossible, like factoring large composite number. The first example, we try to create an algorithm of finding the maximum element of the list. So given a list, like this one, so we have the list consists of 12, and then 8, 13, 9, and 11. We try to find the largest number. So first thing to do is we create a temporary place, and we store this value, the first value, in the first place, or in the first temporary place. And then we set this one is the place for the maximum values. So okay, because this is the first one, we put it in the first, so the maximum is the first number, or 12. And then we try to compare it with the second values, which is 8. We compare it, okay, it's still the maximum values is still 12. So we go to the next element, we check it. Now we have 13, which is greater than 12. So we replace the values inside the temporary place here into 13. And then we check again, and then we find 9, it's still 13, and then find 11, it's still 13. So the result is 13. It also have maximum element running time if we do the finding highest number with the previous solution. It will take, like, if the list has n elements, the worst case scenario is that it takes n steps. Next, the algorithm representation. We need to represent the algorithm that we've created, because we need to explain our algorithm to the programmer as well as to the system analyst as well as the user, if needed. So we need a tools, a mechanism, a concept to introduce, to explain our algorithm, but not in the code. Instead of trying to explain it with the code, we have to explain it in more general way. So we use the algorithm representation tools such as Flowchart. Flowchart is one of the algorithm representation tools or concept that use several symbols like this one, the rectangle is representation of the process or action, and then this one is representation of the branching or the condition, and this one is representation for the looping or repetition. So the flowchart itself can be a sequence, a decision, or a repetition. For the sequence, it executes the process sequentially from the first process, and then after it's done, and then go to the next process until the last process. For the decision, the process or the activity, the action is going to the branching here, and then the condition will be checked. If the condition value is true, or the condition is true, and then do something here. However, if the condition is false, and then do something here. For the repetition, it will do the process repeatedly until the condition became false. So this one, we check the condition first. If it's true, then do the process of the action, sequence of action, and then repeat checking again. If it is still true, then do the action again until repeat again until the condition became false, and we exit from the repetition. Another way to explain our algorithm to another people is using the pseudocode. Pseudocode is something that looks like a code, but it's not really is. This is the pseudocode for the sequence. So action 1 finish, and then action 2, action 3, just like a sequence of the process or the action name. And then for the decision, we use the if, and then break it here, and then we put the condition. If Miss Isna still teaching, and then I do something here. So if this is true, and then do something here. Else, if this is false, maybe like I stop teaching, and then do something here. And if this is the decision, if true, do this one. If false, do this one. Also, we have a repetition here. So while condition is true, so for example, while Miss Isna still teaching, and then I will keep listening. So it will be executed repeatedly until the condition became false. So for example, like I stop teaching, and then it will exit from the repetition, and then end while. Now let's check the example. Write an algorithm in pseudocode that find the average of two numbers. So this is the solution. This is the title of the algorithm, average of 2, and then the input will be two numbers. First input is A, so we create an input namely A, and then create an input namely B, and then add A plus B, and then divide the result by 2, and then return the result, and end. This is the pseudocode. It is not a code, but it looks like a code, and it is easily understood by any other people, not only the programmer. Okay, that's all. Thank you very much.